let me start with this title, Enhancing Student Success in Engineering Curriculum Through Active E-Learning and High-Impact Teaching Practices. Due to a very long title, acronym, ESSENCE is used. And then basically this is the name of the program that we are funded by NSF. And I'm serving as a chair of associate chair of the Mechanical and Aerospace Engineering Department. And then I'm overseeing our undergraduate programs. So today I'm wearing a different hat as a educator rather than the engineering research scholar. And then let me show you very briefly for the research what I'm doing. The lab I'm leading is Miniaturized Multifunctional Devices Lab, MIMUL lab, and then the focus of our research has been on the development of miniaturized sensors, actuators, and then microfluidic components. So we have developed a variety of different types of sensors, including gas sensors and then environmental sensors. And then also we have worked on the microfluidic components, including the drumlet manipulation platforms in the past. The title of my talk is actually the title of the actual project we are funded by NSF. And under this program, NSF Improving Undergraduate STEM Education Program, specifically for Hispanic serving institutions. UCF was designated as a HSI with about 28% of Hispanic / Latino students in our undergraduate programs. And this program by NSF supports 3 different types of tracks. Track 1 is planning or pilot project with just ideas first. And then track 2 is a mid scale. And then track 3, institutional transformation project, is a very large scale, $1 million scale program. And currently, this one, ESSENCE, was funded by track 2, implementation and evaluation project. And basically, this supports the implementation of evidence-based unit, department, or multi-departmental level activities that will enhance the quality of undergraduate STEM education. So let me share this data with you. This program, our program aims at the increasing Hispanic Latino transfer student success. So the focus is on transfer student. Then probably the next question is why transfer student? So if we take a look at the data, UCF currently has almost the equal number of students who are considered as a first time in college, and then those who transferred from the other Florida college systems. And then when we compare them, these 2 groups, we can see a clear actually gap between these 2. For example, students who are from the other colleges as transfer students, their retention rates range from 14 to 15% to 20 to 28% by the time when they reach their 3rd year at UCF, as compared to about 73%. If you take a look at this bar graph on the 3rd bar graph from the left, then you can see the first time in college versus this transfer group student. You can see significant difference between these 2, and then our program aims at addressing this issue. So we wanna implement this in the 2 largest undergraduate programs at the College of Computer Science and College of Engineering and Computer Science, literally the Mechanical Engineering and Aerospace Engineering Bachelor's of Science program currently under our department. So how? We have had pretty actually good efforts among our faculty members who implemented the new ideas, especially during the pandemic period. And based on the preliminary data, we wanted to implement a few changes here. And then one thing that we kind of got some pretty good outcome was the so-called multiple attempt test. When we allow the student to take multiple, attempt test instead of just giving them only one chance to take the exam, we found a significant increase in their self-motivation as well as the actual grade that they earned. So when I say multiple attempts, it doesn't mean that we just give out the exactly same problem set. Rather, problems are selected from the question banks. So it's a little bit randomized, but with the same level of difficulty. So students make extra effort to earn a better degree after we found that after providing this kind of chances. And then that could be summarized from this graph. As you can see, comparison of our test attempts in dynamics course, one of the fundamental courses. We could see by the time when students attempt a third time, the significant improvement of their grades could be found. Especially this improvement could be noted among the transfer students most significantly as compared to first time in college. So we found this is a very effective method to encourage students to make an extra effort. So this is one way. And then also we provide project-based homework assignments instead of giving them a simple question-based homework. And then due to this real-life linkage between the concepts that they learned and then this project, students tend to grasp the concepts better. So this is another facet of this program. And then during the pandemic, we learned a lot about the use of online element, and then also we found that this blended environment could provide the students opportunity to learn based on their pace, also based on a lot of flexibility given to them. When we think about the transfer students, they are the ones who usually have financial difficulties, and then often they work full time while attending the classes and others. So this flexibility actually is another the factor that could help this transfer student more distinguishedly as compared to the first-time college student. So these are some of the things that we are implementing in this program, and then also by making a group of students so that they can work together. We want to provide the social dimension so that they can support each other. And then this team-based approach, we hypothesize that we also will help them progress successfully through this engineering curriculum. So these changes are being implemented in the fundamental engineering courses, the foundation courses that usually transfer students encounter when they come to UCF. So statics and dynamics and thermodynamics. These are the courses that we are implementing with the 3 elements. So we expect to see good outcomes out of this implementation. And then we are working with the experts from College of Engineering Education to trace all the data and then so make sense out of all these initiatives. So in summary, we provide blended learning environment to students so that they can use their time with more flexibility, and then we provide them multiple attempt quiz to encourage them to improve their grades, and then they also motivate them to learn more, and then also we provide them real world problem related mini project. So these are the things that we are doing right now. And then this is not just my effort, but it's rather the collective team effort. So there are many participants, co-PIs and senior personnel on this project. So Dr. Michelle Taub is from the College of Education, and then she provides the framework in terms of educational theory of change. And then Dr. Nader is from our department teaching dynamics. And then Dr. Zorin teaching statics. And then Dr. Paul is teaching dynamics, and then also the implementing this project-based assignments and others. And then the Dr. Woong is in charge of curriculum alignment, which actually provides a conduit to our partner institutions, for example, Valencia College, Seminole College, and so on. And then the Dr. Muniz, she is in charge of HSI initiatives at UCF. Dr. Chen also works with us. He belongs to the College of Science, teaching physics. Dr. Dagley is working on the evaluation element of this project. And then Dr. Putnam is teaching thermodynamics. So this is a timeline. We started implementing these elements collectively from actually this semester and on. We expect to see the impact of this Essence program through this year and next, and then the following year. This is a total 3-year project, but we expect to see lasting impact beyond this program period. So this is currently supported by NSF under IUS HSI award. And thank you for your kind attention.